Number 4 is one of the interpreting graphs problems, and I found this website. I posted this link in the YouTube description and on my website. This table shows that for a 0th order, first order, and second order reaction, you have the 3 different graphs, and I can't show on this window the full, can't show everything at the same time, but you can see the concentration versus time is, it looks like that. But then more importantly, since most people in this class don't know calculus, knowing how to get these straight line plots to determine the rate constant. The 0th order is simply concentration versus time. The first order is natural log of concentration versus time. And the second order is 1 over concentration versus time. This is the one that I believe everyone messed up on the quiz on Wednesday, thinking that this was first order. But since it was concentration versus time and not natural log or anything like that, it's 0th order. And also, it's not a graph of, say, rate versus concentration. So those are really the only 2 graphs that you can have. Actually, I believe she introduced another graph type today. But the 2 primary graphs to be aware of are rate versus concentration and concentration versus time. Part A. What is the order of the reaction with respect to concentration of A? 0 order, because that's what's on the x-axis, and it's 0 order as we know from, there's a picture in the notes that shows 0th order, first order, and second order. And the 0th order is a straight line. I mean, horizontal line is the correct word. 0th is a horizontal line, and then first is shown as a diagonal upward line, and I think you'll find that graph. You'll be able to find that graph. It's one of the few that has rate on the y-axis and concentration on the x-axis in the notes. Part B. This is simply the equation. So it is this equation. This equation always works. Moles, or this is a molarity, not moles. Moles per liter. So molarity to the power of 1 minus the overall order times seconds to the power of -1. This part is always the same, the seconds to the power of -1. So here we have moles to the power of 1 minus, what's the order? 0. Are there any other reactants? And doesn't seem like it, because she doesn't mention any other reactants. So 1 minus 0, because it's 0 order, and then seconds to the power of -1, which, in case anyone doesn't know, that's the same thing as moles per second, because seconds to the -1 is seconds, 1 over seconds.